Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And we will continue our syllabus for this video, okay, about the bipolar junction transistor, and we focus on DC bias circuits and DC analysis. Okay, as we know and as we have learned on the previous class, we have we have six DC biasing configurations. Okay, the first one is a fake bias configuration. This is it's a very basic fake, very basic configuration. And then the second one is the emitter stabilized bias configuration. Next is a voltage divider bias configuration, and we have collector feedback configuration, and we have emitter follower configuration. So all of these five DC biasing configuration we have learned before in our class, face-to-face class. And then for this time, for this video, okay, I will focus on one type of one type of a DC biasing configuration, okay, which is common base configuration. All right. Okay, let's move to the next slides. Okay, before we going further on the common base configuration, we have to remember that no matter what type of configuration of a transistor, okay, is used in, okay, the basic relationship between the current are always the same. Okay, we know that we have six. Okay, we have six. Okay, we have six DC bias configuration. Okay, no matter what type of configuration of a transistor is used in, okay, the basic relationship between the current are always the same. Okay, and the base to emitter voltage is just a threshold value if the transistor is in the on states. Okay, so for example, we have a BBE. Okay, depend on the diode materials. For example, we use a silicon. We assume that our class today we use silicon materials, so our BBE is equal to 0.7. Okay, and then if no, and then we have IE. Okay, IE is a current through the emitter equal to beta plus 1 IB, and IE we can assume that is equal to IC. Okay, IE equal to IC directly. And then the last one is the most important formula that you have to remember and memorize is IC equal to beta IB. Okay, these three formula is a main formula that we can use for all type of configuration. Okay, all right. As this video, we can use this three formula for the common base configuration. Okay, let's see what is a common base configuration. Okay, as we can see in the slide, okay, this is how common base configuration looks like. Okay, common base, as you know that we the base point here, the base point, okay, is directly connected to the ground. Okay, and then we have RE, and then we have a BE. Okay, is a voltage source at the emitter, and then we have a VCC voltage source at the collector, and then RC, and then in the right side we have C capacitor 2, and the left side we have a capacitor 1, and of course we have input voltage and then the output voltage. Okay, how to do the analysis, DC analysis for this circuit? Okay, let's move to the next slide. All right. Okay, here I will show you how to do the analysis to find the IE, to find the VCE, and to find the VCB. As you can see in the slide, they have a three formula that we have to derive, okay, manually. Okay. All right. Okay. Okay, let's start. Okay, firstly, what we going to do is, if you remember that the first step to do the DC analysis, we have to remove the capacitor. So how we have to redraw the circuits, okay, like this. Okay, this is RE, okay, and then minus, positive, minus, positive, so minus, positive. This is our VEE, okay, and then our base is directly connect to ground, and then we have RC here, positive, minus, positive, minus, okay, just redraw without the capacitor. So here we have C2, we have to remove the capacitor, because when we do the DC analysis, means that we have to open the circuits for the capacitor, okay, this one, okay, and then as well for the C1 and C2. Okay, here we have base, okay, this is RC, okay, this one positive, minus, ECC, okay, and then this is a collector, this one we have an emitter, okay, so positive, minus, this is our BCE actually, okay, all right, where the IC is here, this is IC, where the IE is here, okay, okay, you can see. Okay, then next we're going to use Kirchhoff voltage law, KVL, okay, to find the parameter, or the parameter that we're going to derive, okay. Let's say we start first at this loop, okay, we can start first at this loop, okay, we define this is loop 1, okay. Okay, before I forget, where is the VBE? VBE is here, positive, minus, VBE, okay, all right. So now we do the KVL. Okay, we have a KVL at loop 1, okay, like this, okay. So starting with the VE, okay, starting with VE is a positive, okay, so that's we have what, positive VE, okay, and then we have this is plus, minus, okay, so we have minus RE IE, okay, and then we have what, we have here, okay, minus VBE, and then this loop will end at this one, ground, so equal to 0, okay, like this, okay. All right, so based on this, what we can find it actually is the IE, okay, our IE equal to, okay, now we have a PE here equal to RE IE plus P, okay, then we simplify the circuits for the IE equal to, okay, IE equal to Okay, V VE minus V VE. Okay, this is one. Move to the left side. Okay, become minus, and then uh, this one become minus. So VE minus VE minus VBE. So here actually have a RE move to here. RE. Okay. So this is our uh, derivation for the IE. Okay, let's recheck uh, previous slide. Okay, is it same? Okay, same thing. IE equal to VBE minus VE minus VBE divided by RE. Alright. Okay, next. Next, we're going to use this loop. Okay, and then loop 2. Okay. Okay, I'm going to write here because we have a limited space. Alright, so KVL at loop 2. Okay, KVL at loop 2. How? Okay, see. So this is our direction of the loop, and then this is our BCB. Okay, actually is a positive uh, minus BCB. It's okay, either BCB or BBC. If the answer, if okay, no problem. Okay, so where is this one? This one is positive, uh, negative. Okay, that we do. So we have a minus BCB. Okay. Where's minus BCB minus RCIC plus BCC equal to 0. Okay. Okay, and then we can simplify this equation. Okay, our BCB, okay, move to this side, it's positive. So now BCB equal to BCC minus RCIC. Alright, settle the second one. Okay, okay, let me check the formula. Okay, we have the third one here, BCB equal to BCC minus ICRC. Okay, same thing. Alright. Okay, next what we going to do is, okay, we done for loop 1, we have done for loop 2. Okay, we're going to use loop 3. Okay, where is loop 3? We see outside here. Okay, starting from BCC until VE. Okay, this one we can call as loop 3. Sorry, okay, loop 3. Okay, loop 3. All right. Okay, so same thing, KVL at loop 3. Okay, we start with BCC first. So we have minus BCC, we have plus and then we have plus BCE, and then we have plus IERE, and then we have minus BE equal to 0. Okay. Okay, we write here. KVL at loop 3. Okay. Okay. So we have minus VCC plus RC plus VCE plus IE RE minus VE equal to 0. Okay. Okay, equal to 0. Okay. Is it correct? Okay. So we continue to simplify this equation. So what we have, okay, sorry, we have to derive the equation for BCE. Okay. So now our BCE equal to, okay, minus BCC and minus BE move to the right side. So BCC plus BEE, okay, okay, BCC plus BE, all right. And then actually we can replace the IC, okay, equal to IE. Why? Because we already have IE equation. Okay, that's easy. Okay, that's why we replace the IC to IE. And then we already know that the IC is equal to I. This is our formula. Okay. Okay, let's continue. Okay, now we have what? BCE equal to BCC plus BE. Okay, and then we have minus. Okay, because IRC, IE, and IERE is use the IE. Okay, we can combine it. So IE here equal to RC plus RE, okay, and then equal to 0. Okay. 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 So we have BCE equal to BCC plus VE minus IE RC plus RE equal to 0. Okay. So this is our third equation. Okay. So we're going back to the previous slide. See the equation BCE equal to BE plus BCC minus IE RC plus, okay, correct. Okay, so I think that's all for common base computation, how we do the analysis. Okay, I think it's easy one. Okay, okay, the basic is we have to remember that the basic step is we have to remove the capacitor for both sides, and then we will use KVL, okay, for this loop, loop 1, loop 2, and loop 3. Okay, all right. Okay, any question and anything when you want to discuss, okay, we can WhatsApp me anytime about this topic. Okay, so I hope you all enjoy this video and get some knowledge, okay, about the common base configuration. Okay, uh, the last C biasing circuits for the BJT. Okay, next we will continue our class, okay, our online class actually, okay, by using this video. Okay, we will continue on AC analysis, okay, for the BJT. All right, I think that's all for this time. Okay, thank you and goodbye.